Welcome back. How strong are acids or bases in solutions? We know that water ionizes slightly into hydrogen ions and hydroxide ions. The concentration of hydrogen ions and hydroxide ions are equal in pure water. So, water is neither acidic nor basic, but it is neutral in nature. Acid produces hydrogen ions in water. The concentration of hydrogen ions in water increases when an acid is added to water. That is, the acidic solution have excess of hydrogen ions. One more thing we have to notice that even the acidic solutions contain hydroxide ions which comes from the ionization of water, no? But the concentration of hydroxide ion in acidic solutions is much lesser than that of hydrogen ions. That is the reason we are calling it as acids. On the other hand, base produces hydroxide ions in water. The concentration of hydroxide ions in water increases when a base is added to water. That is, the basic solution have excess of hydroxide ions. We have to note that even the basic solutions have hydrogen ions which comes from the ionization of water, but the concentration of hydrogen ions in basic solution is much lesser than that of hydroxide ions. We have already studied that acid-base indicators can be used to distinguish between an acid and a base. We know that dilution decreases concentration of hydrogen ions and hydroxide ions in solutions. How can we find the amount of these ions in solutions? Or how can we find the strength of acid or base in solution? For this purpose, we are using universal indicators, which is a mixture of several indicators. The universal indicator shows different colors at different concentration of hydrogen ions in a solution. In 1909, Sorensen devised a scale known as pH scale, on which the strength of acid solutions as well as basic solutions could be represented by making use of the hydrogen ion concentration in it. That is, pH scale is a scale for measuring hydrogen ion concentration in a solution. In the term of pH, letter P stands for a German word potens, which means power, and the letter H stands for hydrogen ion concentrations. On the pH scale, we can measure pH from 0 to 14. pH should be a number which indicate the acidic or basic nature of a solution. Higher the hydronium ion concentration, lower is the pH value. The pH of a neutral solution is 7. So the pH of pure water is 7. That is, water is neither acidic nor basic in nature. The value less than 7 on the pH scale represent an acidic solution. For example, a solution with pH 5 will be acidic in nature. Please note that more acidic a solution is, the lower will be its pH. That is, if we are taking two solutions with pH 1 and pH 4, the solution with pH 1 is more acidic than the solution with pH 4. The solutions which having pH values 0, 1, 2 and 3 are usually considered as strong acids. So we could say that lower the pH, the stronger is the acid. As the pH increases from 7 to 14, it represents an increase in OH minus ion concentration in the solution, that is, increase in the strength of alkali, or we can say that increase in the strength of base. For example, a solution having pH 11 will be basic in nature. The more basic a solution is, the higher will be its pH. That is, a solution of pH 12 is much more basic than a solution of pH 8. The solution having pH 11, 12, 13 and 14 are usually considered as strong bases. And we can say that the higher the pH, the stronger the base. The common pH scale having pH values from 0 to 14. At pH 7, a solution is neutral. As the pH of solution decreases from 7 to 0, the hydrogen ion concentration in the solution goes on increasing and hence the strength of acid also increases. On the other hand, as the pH of the solution increases from 7 to 14, the hydroxide ion concentration also increases, due to which the strength of base also increases. Now you can see pH values of some common substances on the screen. pH of blood is 7.4, lemon juice is 2.2 and gastric juice, that is digestive juice, its pH is 1.2 and pH of milk of magnesia is 10 and sodium hydroxide solution is about 14. The strength of acids and bases depend on the number of hydrogen ions and hydroxide ions produced respectively. If we take hydrochloric acid and acetic acid of the same concentration, say 1 molar concentration, then these produces different amount of hydrogen ions. The acids that give rise to more hydrogen ions are said to be strong acids, and the acids that give less hydrogen ions are said to be weak acid. Hydrochloric acid ionizes completely and gives more number of hydrogen ions, whereas acetic acid ionizes partially only and gives less number of hydrogen ions. So they are considered as weak acids. Next topic, importance of pH in everyday life. pH plays an important role in many activities of our everyday life. Our body works within the pH range of 7 to 7.8. Living organisms can survive only in a narrow range of pH change. When pH of rainwater is less than 5.6, it is called acid rain. Too much acid rain can lower the pH of lake water or river water to such an extent that the survival of aquatic animals become difficult. The high acidity of lake water or river water can even kill the aquatic animals. Calcium carbonate is added to neutralize the acid that comes from acid rain. This prevents the fish in the lake from being killed. pH of the soil. Plants require a specific pH range for their healthy growth. If the soil is too acidic or too basic, the plants grow badly or do not grow at all. The soil may be acidic or basic naturally. The pH of the soil is affected by the use of chemical fertilizers in the field also. Chemicals can be added to soil to adjust its pH and make it suitable for growing plants. If the soil is too acidic, then it is treated with basic materials like quicklime, slaked lime or chalk. These bases react with the excess acid present in the soil and reduce its acidity. If the soil is too alkaline, then its alkalinity can be reduced by adding substance containing acidic materials like decaying organic matters. We can ourselves check the pH of the soil. For that, we have to take 2 grams of soil in a test tube and add 5 ml of water into it. Shake the test tube well, filter the content of the test tube through a filter paper and collect the filtrate. Find the pH of this filtrate by using the universal indicator paper. This will give the pH of the sample. Next one, pH in our digestive system. It is very interesting to note that our stomach produces hydrochloric acid. It helps in the digestion of food without harming the stomach. During indigestion, the stomach produces too much of acid and this causes pain and irritation. To get rid of this pain, people use bases called antacids, which means anti-acid. Antacids are a group of mild bases which have no toxic effects on the body. Being basic in nature, antacids react with excess acid in the stomach and neutralize it. This gives relief to the person concerned. Magnesium hydroxide, which is called milk of magnesia, and sodium hydrogen carbonate are examples of antacids. Next one, pH changes as the cause of tooth decay. Tooth decay starts when the pH of the mouth is lower than 5.5. Tooth enamel, made up of calcium phosphate, is the hardest substance in the body. It does not dissolve in water, but is corroded when the pH in the mouth is below 5.5. Bacteria present in the mouth produce acid by degradation of sugar and food particles remaining in the mouth after eating. The best way to prevent this is to clean the mouth after eating food. Many toothpastes contain bases to neutralize the mouth acids. So using the toothpaste for cleaning the teeth can neutralize the excess acid in the mouth and prevent tooth decay. Self-defense by animals and plants through chemical warfare. Many animals and plants protect themselves from their enemies by injecting painful and irritating acid and bases into their skin. For example, when a honeybee stings a person, it injects an acidic liquid into the skin, which causes immense pain and irritation. For getting relief from that, we should rub a mild base like baking soda solution on the stung area of the skin. This is because, being a base, baking soda neutralizes the acidic liquid injected by the bee sting and cancels its effects. When a wasp stings, it injects an alkaline liquid into the skin. So, if a wasp stings a person, then rubbing a mild acid like vinegar on the stung area of the skin gives relief. This is because, being an acidic substance, vinegar neutralizes the alkaline liquid injected by the wasp and cancels its effects. An ant sting injects methanoic acid, that is formic acid, into the skin of the person, causing burning pain. Being acidic, an ant sting can be neutralized by rubbing a mild base like baking soda on the affected area of the skin. Some plants also give painful stings. When a person happens to touch the leaves of nettle plants accidentally, the stinging hair of nettle leaves inject methanoic acid into the skin of the person, causing burning pain. Here also we can use baking soda for getting relief. I hope you understand the topic. Thank you for watching.